What's good, my analysts, and welcome back to the Analyzing PowerShell Payload series. This is episode 5, and in this one, we're going to be building upon all the lessons we've learned from the previous examples to take a look at a moderately obfuscated payload that's going to be adding a little bit of trickery, some additional techniques to try to trip up an analyst or like a sandbox or an automated detection. But don't worry if we followed our same methodologies that we've learned over the previous examples. You'll see it's pretty straightforward. You just got to look for a few additional things. And I'm here to walk you through it. So let's dive right in. Okay, so I'm going to burn through the first bit of this rather quick because this is all review. We understand that we see PowerShell.exe running -e. We can assume that's dash encoded command. If it's dash encoded command, we can assume it's base64 data. So the first thing we need to do is going to pop in our handy dandy regular expression to just grab that base64 data. You guys are probably, I'm going to go fast because we've done this a million times. And then we do from base64. And then we know from our previous example, all these dots are null bytes. And what we learned before is we can just do this remove null bytes and it makes it nice and pretty. Okay, so this looks interesting. It's human readable, although very different from what we've seen before. On the previous ones, they mostly, the second layer of obfuscation usually fell into that don't kill my cat kind of shellcode executing template where we would see it. We know where the shellcode is and it would do maybe some trickery with an XOR or something like that, but it, they looked very similar. This one's doing something kind of tricky to try to trip up some sandboxing or automated detections here. We could see that the first thing it's doing is it's taking all of the code that is required to access some DLLs that are important to executing shellcode and reading that into a string. It's just going to be a string value in a variable. And then it's going to be doing some basic replace functions. We learned this before. This is just string match replace to get around to add things like create thread and DLL import. So based on this, we can look at this and say, okay, so we know it's doing a DLL import of kernel32.dll and msvcrt.dll. So even though we kind of know what this is going to be, at the end, let me explain like methodology, like some keywords we can key in on. So if I see those three things, DLL import kernel32.dll and msvcrt, what does that mean? So kernel32 DLL exports multiple routines that can be used to interact with the Windows OS, like to do things like allocate memory, create processes, or interact with anything in the file system, basically. So it's a really good DLL to have access to, obviously, for executing evil things. We would want that. The next thing is the msvcrt.dll, and this is the standard C compiler that is in all Windows versions since like Windows 95, and it's always going to be there by default. And the idea here, by importing this, it's going to find all the functions that msvcrt.dll exports and add them to a library file. So the code here can reference them, which makes it a great target for a payload because now it's going to be able to interact and do things with the Windows OS by having access to the library, those two libraries and all of their exports. So we can safely assume right there that based on those three things that this is a shellcode loader. But for analysis, we don't really need to worry about that other than we're thinking still shellcode, even though it's not the don't kill my cat thing that we're familiar with. Now this looks different. So this is saying NF, the variable, we have a string of a bunch of stuff, just junk. And it doesn't look like anything we've seen before. It doesn't look like the hex data from one of the example, and it's certainly not base64, and we don't see our base64 keyword or the gzip compressed. So what is it? We don't know what it is, but we know that this is something weird and probably obfuscated data, but we'll keep moving along to get some more clues. The next thing we see here is that it's using the command add type. Now, this is interesting because add type in PowerShell allows you to create a custom .NET class. And we can see that it's referencing KQ, right? Our shellcode loader from above here. So it's saying, I don't want to use the built-in stuff. Let me create a custom one. This is kind of an evasion thing to say, let's not, load it directly. Let's create a custom one that is referencing, those DLLs that we know are associated with shellcode. that dash pass is for pass-through. Dash M is for the member definition. So we're defining what I want my class to be. In this case, it is the shellcode loader. The name is the name. And then dash NM or names here. This is namespace. So one of the things, if you guys ever, if you hop out of this and you want to find something cool about PowerShell, and there's, Daniel Bohannon who wrote invoke obfuscation. PowerShell will try to auto-complete things. So instead of writing dash namespace, if you just do dash names, PowerShell is going to say, oh, I bet he meant, dash namespace. And here we see it references a string value of W or YWQ. And then down here again, we can see they're doing another replace, and now they're saying, oh, what we really mean there is YWQ is Win32 functions. And what that does is referencing that namespace, which allows it to directly interact with the Windows API. And then finally, we see our byte array, right? So we've seen this before in the other ones where it's, so we know this is byte array and it's referencing this thing, but that's not valid. It won't be loaded. So to get around that, they're doing multiple replaces. And the way PowerShell will evaluate this is just directly in order. So it will say NF, apply this first reply function where it's saying replace all the less than, that's less than, right? All the less than with BxDx, and then from the output of that, replace BxD with 0. Okay, we can do that. So we'll keep that. And now we know that this is obfuscated and we're good. And the remainder of the code here is that the payload is creating a thread to execute our shellcode within a defined virtual address. You can look at create thread, virtual protect, memset, assume that that means it's creating, it's executing our evil in memory in a piece of allocated space that is defined above. Okay, for the purposes of this, you don't really need to know that, but we still know it's shellcode, so let's work on it. We can take our same methodology where we work from our obfuscated data working out. The only thing obfuscated here is NF. So let's grab this. We can do the same kind of approach as before, although it's not base 64, so we're going to have to use a different regular expression. But it's pretty easy. It's structured just the same. We're looking at letters, numbers, a less than sign, and commas. So we'll just add that there, and that works. Now I'm going to leave it. I'm going to add the remaining things on here just so we can step through it and it's clear. So we know that we need to do 2 replaces on this as well. So I'm going to add a replace to our recipe, but I'm not going to do anything with it. Oh, let me just disable it. And then I'm going to add another one because we got to do 2, right? Okay, so the first thing we need to do is we're going to take NF and we're going to do a find the less than, replace that with BxDx, and then we need to do a find a BxD and replace that with a 0. Okay, and when we do that, here, we're going to change this to list our matches so we can apply our find to that. We're going to apply our first find, it's going to change it, and then the second one, and boom, we know. If you don't know what this is hex data. Clear indicator is it starts with 0x. And fortunately in CyberChef, we have a from hex command, and we can apply that to our recipe, hopefully, and bada bing, bada boom, we have our C2 IP address. So now you know how to extract the tactical intel from a payload, a custom payload that's leveraging hex data that is obfuscated within the shellcode itself. In the next episode, we'll be actually getting out of CyberChef completely, and we're going to try to do some analysis on a DLL that's packed inside of a PowerShell payload.